Welcome to the next topic, and the topic is design of columns. So, column is a structural member which is subjected to compressive loads if the if the height if the effective height of the compression member is less than or equal to 3 times of its least lateral dimension breadth, then it is called as a pedestal. So uh, that is the effective height of the column is in between 3 times to 12 times of its least lateral dimension, then it is called a short column. If the effective height of the column is more than 12 times of its least lateral dimension, then it is known as a long column. Every RCC column consists of two types of steel. First one is a longitudinal steel, that is a main bar, and next one is it shares the applied compressive load according to area of steel and the grade of the steel. It takes care of the bending in tension developed in the column due to eccentricity of the load. It reduces the overall size of the column by sharing the applied load. So tie bar transverse steel. Transverse steels are provided to support the longitudinal steel and to control the buckling of a longitudinal steel. It provides confining to the concrete. It also maintains the exact size of the column. It also helps to get vertically of the column. The design of the transverse steel is semi-empirical. Design aspects of the RCC column, that is according to IS 456 2000. um, that is there are following design aspects. The first one is the cross-sectional area of the cross-sectional area of longitudinal reinforcement shall be not less than 0.28 percentage of the gross cross-sectional area of the column. It shall be it shall be not more than 6 percentage of the gross cross-sectional area of the column, and minimum longitudinal bars are required to take care of the bending tension developed by eccentricity loads. Maximum steel has been restricted to uh, uh, pack the concrete properly. And third condition is the longitudinal bars are to be lapped, then the percentage of the steel shall mutually not exceed 4%. The minimum number of longitudinal bars shall be 4 in rectangular column, but in case of circular, it shall be 6. The bars shall not be less than 12 mm in dia. The spacing of the longitudinal bars along the periphery shall not exceed 300 mm. And next case of a pedestal, the minimum area of the longitudinal steel shall be 0.15 percentage of the cross-sectional area. The tied column shows a brittle failure where the longitudinal bars buckles between two transverse steels. And next one is a helically reinforced column. Spiral shows ductile failure, and a helically reinforced column can carry 5% or more than the similar tied column. And the dia of the lateral tie transverse steel shall be 1/4 of the dia of largest longitudinal bar are equal to 66 mm, which is greater. Next one is the pitch of the spacing of lateral tie shall not be more than the least of the following data. So first one, the least lateral dimension of the column, 16 times of the smallest dia of the longitudinal reinforcement, and third one is 300 mm. And the next condition is the pitch of the helical reinforcement or spiral shall be not less than 25 mm or t 3 times of the dia helicals, whichever is greater, the pitch of the helical shall not exceed 75 mm or 1 by 6 of the core dia, which is lesser. All the columns shall be designed for minimum eccentricity equal to L by 500 plus B by 30, that is equal to 20 mm, whichever is greater. And next, the unsupported length between the restraint shall not exceed 60 times the least lateral dimension if one end of the column is unrestrained. That is then total unsupported length shall not be exceed 1100 b square divided by d, where b is breadth of the column, smaller dimension, and depth of the column. And the clear cover for main steel shall not be less than 40 mm, but it can be reduced to 25 mm in the case of small size in column having dimension of 200 mm or less than or less, and the dia of the main base should not be exceed 12 mm dia. The internal angle of the lateral tie shall not exceed 135 degree. The maximum permissible strain in concrete in direct compression in the limit state method is 0.002. So next one is there are various types of column is there. We have to see in one by one. The first column is tied column, that is lateral tie. These are some pictorial example of lateral column, and this one is stress distribution diagram. So and then y-axis is load and x-axis is deformation, yield point and brittle failure. And the next one is compressive load, longitudinal bars, buckling of the longitudinal bars, lateral trip. Next one is spirally reinforced, that is helix. This is the helix column, and it has moves on a zigzag manner, and that is a stress distribution diagram like this. Next one is composite column, and another one is oxide loaded column, and uniaxially eccentrically loaded column. And if E is small, these are the condition of the columns. And next one is biaxially eccentrically loaded column, and then condition. So first one is design of an axially loaded column. That is, we have to find out the design of loaded column. P is working load without load factor, and assume area of the longitudinal steel temporarily say 1% to 2% of cross-section area. And the third one is limit state method. These are some pictorial example of problem. This one is problem. So next we are going to see the problem. Is it a RCC short column with 300 mm, 300 by 300 mm square cross-sectional area is made of a M20 and Fe 415 steel. It is reinforced with 4 mm, 4 number of bars in 20 mm dia. It is subjected to concentrated axial load. Determine the ultimate axial load carrying capacity. Neglect the reduction in the area of concrete due to the steel bars. First, we have to find out the area of cross section, that is 90,000 mm square, and AAC, and 4 into pi by 4 into 20 square. P is nothing but PC plus PS, and finally the load is 1201 kilometer. So next we are going to see the problem of determine the size of the square column subjected to ultimate load 1500 kilonewton. Assume the steel assume steel equal to 1.5 percentage of gross area. Use M20 and Fe415. Assume eccentricity is within 5 percentage of the column size, and E is less than or equal to 0.05 B. PU equal to 0.43 into FCK EG plus 0.67 into FI EAC. So AG is nothing but 124473.58 mm square, and finally B is nothing but 360 m. So the next problem is design a RCC column to carry a working load of 1000 kilonewton. The total length of the column is 8 meter. Use M equal to 13.33 and Fe 415 megapascal. Assume the both ends are held in position, but only one end is restrained against the rotation. Now, working stress method, P equal to sigma Cc AC plus sigma AC into AC only for short column. We have to find out AG is nothing but V equal to 390 mm and check for effect L effective divided by B, that is equal to 16.4. It is greater than 12. Next, B is 400 mm and A is equal to 1600 mm square. Finally, the diameter of the bar is 16 mm. The bar made up of the made of the 6 mm and 2 to 250 mm spacing. So these are the cross-sectional dimension of the steel bar. So thank you. We will see the problem in next videos. Thank you.